Good morning, everybody. Shlama Mohon. This is a simple circuit back to basic. It's an inverter, sine wave inverter. Now the principle comes from the literature on timer 555. I'm definitely sure you have seen all of these diagrams before. What it's made of, it's very simple electronics, and this electronics then feed the transformer. This transformer originally came from electronic amplifier, which I took apart and I used it for this project. It's simply 6 volts that converts it maximum to 40 volts. I've selected a sampling rate of pulse width modulation based around about 40 kilohertz, which suits this transformer, but anything from say 20 to 40 kilohertz should be alright. The main reason for that is that the transformer will appear like a low pass filter at this higher operating frequency, so the 50 hertz power will go through it quite nicely, and it will appear as a typical sine wave. There's a capacitor there, 1 microfarad, and the purpose of that is to help a bit extra to shape the 50 hertz sine wave. Okay, now back to what I've done down here. I've got a meter which actually will monitor the current going from the battery to the electronic circuit itself, and also I'll be monitoring it on the oscilloscope. In a sense, I'll check the sine wave, the quality of it, and also the voltage that's coming out of it can be measured with the voltmeter. What I have is a load which is in the form of a fan which operates between 220 to 240, and I've got some lamps which they also operate between 200 to 240. I've got some switches, some typical GPO power outlet which the fan is plugged into, and also some power switches for the light for the whole thing to be switched on and switched off. And then I'll show you as how the load will actually be increased each time that you switch a light on. Now okay, let's have a bit of check as whole thing how it works. It basically has got a MOSFET H bridge, and you have the timer in there which does all the pulse width modulating. And right now we are in a position as to put the power on and see as how everything will function. Okay, right now I've got the battery all set up. As you can see, it's a 12-volt battery. It's got 7.2 amp hours, and so I'm ready to turn the power switch on, which at the moment is the first button there, the black one marked, and we're gonna see a display that will come on the oscilloscope. Here's this oscilloscope, and here's the electronic board. Okay, we're gonna put the power on. There's a switch. Okay, there's a bit of current going through at the moment, which is mainly the circulating current in the transformer in conjunction with the capacitor, but that's fine. Okay, let's go and look at the oscilloscope now. Okay, 50 hertz. At the moment, this circuit board has been designed for 50 hertz, but can easily be modified for 60 hertz. Alright, so that is the I know there's a bit of flickering on the oscilloscope. Unfortunately, it's not a storage oscilloscope, so that will be flickering for a while like that. Okay, now we're gonna put the power on, and this switch, the first switch we're gonna put on is the light switch. There's the light switch, and there's still the oscilloscope, 50 Hertz, same level, no difference, hasn't changed much. Now we're gonna put the fan on. There's the fan. It's nicely blowing air. Okay, going back to oscilloscope just to check the waveform. It's still there. Sine wave. Okay. Now we are about to increase more. By the way, as we increase the load, the current also goes up. At the moment we are at 1.92 amps. Okay, which is taken from the battery. Now we're gonna put the other light on. Current has gone up. Okay, light off. Current goes down and the fan is on. Now we'll just switch off the fan. Signal is still there. Okay, I'm gonna switch off the other light. We are back to the main circuit. It's a very simple circuit. It, as I said, is back to basic, using a simple pulse width modulation as per what they have in the literature. Okay, right now we can see that the magnitude of voltage is 233 volts. This is what's been set by the potentiometer down here. Now I'm going to increase the load to the next one. Next light on. Still relatively close. What I've got is an automatic sensor that detects the level of voltage and adjusts accordingly. Okay, and the sine wave is still on. It's quite good, the presentation of that. Okay, so this. Okay, these are just the wavelength for half the cycle. The other negative side of the sine wave also has got modulation of its own, but because this is only a 2-channel oscilloscope, I cannot show you the other one. But obviously, as I stretch the time base, you can see that there are in fact pulses running through. These are the pulses that represent the modulation for the sine wave. I hope you enjoyed the project, and if you want to make anything similar, please send me an email below this video description, and I've got my email address there, and for a very modest fee I can send you the actual circuit diagram and explanation as how the whole lot works. Thank you for watching.